Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva from Student the Brand. Today we are going to discuss about light reflection and refraction. Today we are going to discuss about light reflection and diffraction. Here, the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. So incident ray, reflected ray, undeviated line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected and deviated line is called angle of deviation. So here you can observe the angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Is called angle of deviation. Angle of deviation. So here I am considering. The angle between incident ray here. Loss of reflection. If you are taking loss of reflection. Loss of reflection. Loss of reflection. Loss of reflection. Okay. So the angle between incident ray and normal line. So angle between incident. So in first one incident ray, reflected ray, normal line. Loss of reflection or incident ray, reflected ray, normal line lies in the same plane. Second one, angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incidence is equal to angle of reflection. So incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. Okay. So angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So these are the laws of reflection. Laws of reflection, I am taking this the angle. That angle is called 180 degrees. This angle is called 180 degrees. 180 degrees, that is angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Now angle of, in the place of angle of incidence, so I am substituting angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence. So we can also take angle of incidence is equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. So these are the laws of reflection. Laws of reflection are okay. So here you can see incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Incident ray, reflected ray, normal line lies in the same plane. Angle incident ray, reflected and normal lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So if you are taking angle of deviation formula I'm considering. Now we can take one more. So now I'm considering here regular reflection, regular reflection, regular reflection, regular reflection, regular reflection. So I'm taking this the incident ray. So if you are taking the plane mirror, if I'm considering the plane mirror, incident ray, if the all light rays are incident light rays are parallel to each other, then reflector light rays also parallel to each other. So incident light rays are parallel. Incident light rays are parallel. Incident light rays are parallel. Then reflector light rays also parallel to each other. Incident light rays I'm taking parallel. If reflector light rays also parallel to each other, that type of reflection is called regular reflection. Incident light rays are like if you are taking this is the incident beam, incident beam, incident beam, incident beam. So this will be the reflected beam, reflected beam, reflected beam I'm considering. So light rays are parallel to each other. So incident light rays are parallel to each other. If reflector light rays also parallel to each other, if reflector light rays also parallel to each other, this type of reflection is called regular reflection. Regular reflection. Coming to irregular reflection or diffused reflection, irregular reflection or diffused reflection, irregular reflection or diffused reflection. If you are taking, so this is the irregular surface I'm taking, and so surface is irregular surface is irregular surface. Okay, so incident light rays are parallel, but reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. So irregular reflection, reflector light rays are not parallel to each other. This type of, so irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. Irregular example we can take a book, wall. Okay. Regular reflection we can consider. Regular reflection takes place on smooth surface, plane mirror, and plane mirror takes place and also still water. So this is about regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular reflection and irregular reflection. So if you are taking now, after regular reflection, irregular reflection, we'll discuss about object and image. Object and image. So here I'm considering plane mirror. This is the plane mirror. I'm taking this is the plane mirror. So here, this is the object, real object, real object. Light rays are coming from this point. If the light rays are coming from this point, if the light rays are coming from this point here, after reflection, those light rays are moving away from it. After reflection, those light rays are moving away from it. After reflection, those light rays are moving away from it. If you are extending those light rays, those light rays will move at one point. If you are taking these light rays, will move at one point. So their image is forming. That is a virtual image. Virtual image, real object. So from this point, light rays are coming. From this point, light rays are coming. After reflection, those are moving away from the principal axis. If you are extending the incident light rays, incident light rays are meeting at one point. That is a virtual image. So I'm taking one more. Okay. So I'm considering here light rays are coming from certain point. So from infinity, if you are taking light rays are coming from infinity after reflection. Though light rays are meeting at one point. So after reflection, light rays are meeting at one point. So if you are extending those incident light rays, so if you are extending these incident light rays are meeting at one point. Real image and virtual object. Observe one point here. So here if you are considering here, okay, so real object, from this point light rays are coming. So here we are extending this reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Here, so incident light rays after reflection, those light rays are meeting at one point. Their image is forming. That is a real image. If you are extending these incident light rays, incident light rays are meeting at one point. Their object is, that is a virtual object. So now you can understand one thing. Real object, virtual image. So virtual object, real image. So if you observe these two diagrams, if you are observing these two diagrams, so real object, virtual image, real image, virtual object. So we are extending the reflector light rays. Reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Here, directly reflector light rays are meeting. Their image is forming. That is a real image. So we are extending. So from a real object, light rays are coming. We are extending the incident light rays. those incident light rays are meeting at one point, their virtual object. So the point of intersection of extended reflector light rays is called virtual image. The point of intersection of reflector light rays is called real image. Virtual image, real image. The difference is we are extending the reflector light rays, those are meeting at one point. Here reflector light rays are meeting directly at one point. Here, so from the point, from the object light rays are coming, we are extending the incident light rays, by that, so virtual object is formed, virtual object is there. So the point of intersection, the point of intersection is called, the point of intersection of extended incident light rays. The point of intersection of extended incident light rays is called virtual object. Virtual object. So this is about 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 okay. So image and object, virtual image and real image. So if you are seeing this one, by this one we can understand one thing, by this one we can understand one thing. Object is real, object is real, object is real, image is virtual, object is virtual, image is real. So we can understand one thing by this. By this we can conclude that. By this we can conclude that. By this we can conclude that object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. So this is about virtual object and real image, virtual object and real image, virtual object and real image, virtual object and real image. After that, so we are going to one more topic. We are going to discuss about one more topic, that is next one. We are going to discuss about nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Okay. So I'm taking here plane mirror. So object is here. So one light ray I'm taking like this. Another light ray. If the light ray is passing along the normal line, if the light ray is passing along the normal line, it reflects into the same path. If the light ray is passing along the normal line, it retraces its original path. So retrace its original path, it moves in the same direction. Retrace its original path, so same direction it reflect back into the, so reflect back in the same path. Okay, so retrace its original path also. So like that, if you are taking along this one, this is a reflected ray, I'm taking this a normal line, and I'm considering one more here, reflected ray I'm taking here. So this is a normal line, this is a normal line. So if you are extending, how many light rays are required to? So how many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So I'm taking here. So AB, A dash and B dash, AB and A dash, B dash, AB and A dash, B dash, AB and A dash and B dash. Next. So object is real, image is virtual. In this case, I am considering here. So here I am taking object is real. First point is object is real, image is virtual. Object is virtual, image is real. So in the previous case, I explained, I given one example that is object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. So if object is real, image is virtual. Object is virtual, image is real. So that is called. So that is the reason. So if okay, object is real, image is virtual, object is virtual, image is real. Very, very important. Next one, we are going to the next one. Here object distance is nothing but distance between object to mirror, distance between object to mirror, distance between object to mirror, distance between object to mirror. So this the middle one is mirror. Middle one is mirror. The distance between object to mirror is called object distance. Distance between mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. In the plane mirror, object distance is equal to image distance. Object distance is equal to image distance, and also height of the object is equal to height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. So fourth one you can see. Fourth one is about Fourth one is also shows a lateral inversion. This also shows lateral inversion. The phenomena of conversion of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. This mirror image is called lateral inversion. The phenomenon of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Lateral inversion. Lateral inversion. So what is the lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. You can see that. You can see the ambulance written on the vehicle. It is in the mirror image. So it is in the mirror image. If you see in the mirror, it appears normal. So now you can see, I am giving one question. That question is from A to Z capital letters. From A to Z capital letters. Which letter does not show lateral inversion? Which letter does not show lateral inversion? You can comment in the comment section. Right from starting, my letter is O. Oh. So my capital letters. Capital letters, take capital letters A to Z. Which letter does not show letter inversion? You can comment in the comment section below. I am saying letter. Oh, next your choice. Choice is yours. So start type in the comment section. Which letter does not show lateral inversion? Next one, spherical mirror. Spherical mirror. Spherical mirror. Mirrors. Spherical mirror. Mirror. Spherical mirror. Mirror. Spherical mirror. Mirror. Spherical mirror. Spherical mirror. Spherical mirror. Mirror. Spherical mirror. Spherical mirror. Spherical mirror. So now I'm considering here. So we can see so a part of the sphere is called spherical mirror. A part of the sphere is called spherical mirror. Okay. A part of the sphere is called spherical mirror. A part of the mirror which is in the form of curved shape. The mirror which is in the form of curved shape is called spherical mirror. The mirror which is in the form of curved surface is called spherical mirror. Depending on the reflection, there are two types of mirrors: concave mirror and convex mirror. Concave mirror and convex mirror. Concave mirror and convex mirror. So I'm taking reflection. So concave mirror I'm considering here. So this is the pole, focus, center of curvature, pole, focus, center of curvature. So I'm taking, so okay, we didn't discuss till this point. So let it be mirror. Only mirror you can take. So mirror I'm considering, concave mirror. Concave mirror. Concave mirror. So whenever the light rays are falling on it, whenever the light rays are incidenting on it, after reflection, the light rays are meeting at one point. After reflection, the light rays are meeting at one point. So concave mirror is also known as converging mirror. 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 Convex mirror. Convex mirror. Convex mirror. Convex mirror. Convex mirror. Convex mirror is also known as diverging mirror. Diverging mirror. Convex mirror is known as converging mirror. Concave mirror is known as converging. Convex mirror is known as diverging. Convex mirror. Convex mirror is also known as diverging. Diverging mirror. Concave mirror is known as converging mirror. Convex mirror is also known as diverging mirror. Why we are calling this like this? Whenever the light rays are incidenting on it, after reflection, the light rays are moving towards the principal axis. After reflection, the light rays are moving towards the principal axis. So concave mirror, after reflection, the light rays are moving towards the principal axis. Coming to the convex mirror, after reflection, light rays are moving away from the principal axis. After reflection, light rays are moving away from the principal axis. That's why it is called diverging mirror, converging mirror. So after reflection, light rays are moving towards the principal axis. That's why converging mirror. After reflection, light rays are moving away from the principal axis. That's why it is called diverging mirror, diverging mirror, diverging mirror, diverging mirror. Next one. So we can take terms related to spherical mirror. 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 Spherical mirror. Terms related to spherical mirror. So I'm considering here this is a part of the sphere. This is a part of the sphere. So here center of the imaginary sphere. Center of the imaginary sphere. So C is the center of the imaginary sphere in which mirror is a part. C is the center of the imaginary sphere. C is the center of the imaginary sphere in which mirror is a part. So midpoint of the mirror is called pole. Midpoint of the mirror is called pole. Midpoint of the mirror is called pole. Center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. So midpoint of the mirror is called pole. Center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part is called center of curvature. So midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. Line joining of center of curvature and pole is called principal axis. Principal axis. First one is center of curvature. Second one is pole. Third one is principal axis. Principal axis. Principal axis. Principal axis. And the fourth one, the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature and pole is called radius of curvature. Radius of curvature. Radius of curvature. Fifth one is after reflection. After reflection, light rays are meeting at one point. After reflection, light rays are meeting at one point. So I'm considering here after reflection, light rays are meeting at one point. After reflection, light rays are meeting at one point. After reflection, light rays are meeting at one point. After reflection, light rays are meeting at one point. That is called focus. After reflection, light rays are meeting at one point. After reflection, light rays are meeting at one point. That is called focus. So, or simply, actually, principal focus, simply we can say focus. So the distance between focus to pole is called focal length. 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 Sixth one is principal focus, are simply called focus. The width of the mirror, a diameter of the reflecting surface. Width of the mirror, a diameter of the reflecting surface is called aperture. 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 We can say The width of the mirror, diameter of the reflecting surface is called aperture. Center of curvature, center of the imaginary sphere, center of the imaginary sphere, center of the imaginary sphere in which mirror is a part is called center of curvature. Midpoint of the mirror is called pole. So principal axis, the line joining of center curvature and pole is called principal axis. Line joining of center curvature pole is called principal axis. Distance between center curvature to pole is called radius of curvature. After reflection, all eight rays are meeting at one point. That is called focus. So focus, the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. So width of the reflecting surface, width of the reflecting surface, width of the reflecting surface. So reflecting surface is called aperture. So this is about terms related to spherical mirror. Terms related to spherical mirror. Right? Next. So 5 minutes break. Till 10:20 I'll start. So now, ray rules of concave mirror. Ray rules of concave mirror. So concave mirror and convex mirror will discuss. Ray rules of concave mirror and convex mirror. Concave mirror and convex mirror. Convex mirror. So first one, so pole, focus, center of curvature. Light rays coming from infinity after reflection passes through focus. Second one, so pole, focus, center of curvature. Light ray passing through focus. Light rays coming from infinity after reflection, it passes through the focus. Light rays come passing through focus after reflection moves towards infinity. So pole, focus, center of curvature. Light ray passing through center of curvature. Light ray passing through center of curvature reflect back into the same path. Coming to fourth one. So pole, focus, center of curvature. Light ray is incident at the pole. So coming to fifth one. So pole, focus, center of curvature. Light rays parallel to the principal axis after reflection passes. It passes through focus. Second one. So pole, focus, center of curvature. Third one. So pole, here I am considering here. So light ray is coming parallel to the principal axis after reflection passes through the focus. Light rays passing through the focus after reflection moves towards infinity. Light rays passing through center of curvature. It reflects, it retraces its path. So light rays incident at the pole, it reflect back. So whereas convex mirror you can see, whereas convex mirror you can observe, convex mirror, light is incidenting, it reflect back. So here you can consider light ray is passing through the focus after reflection moves towards infinity. Light ray passing through center curvature traces its original path. Light is incidenting at the pole, so it reflects back. Okay, so this is about concave mirror. So ray rules and ray rules, concave mirror and convex mirror, concave mirror and convex mirror, concave mirror and concave mirror and convex mirror ray rules. Now we will discuss about concave mirror image formations. So be ready. Hmm. So only ray rules and image formations enough. Okay, so they will ask about ray rules and image formations only. So object is at infinity. Object is at infinity. Image is forming at focus. Hello, I am Imperior. I am here. I am in live. Okay, so now happy. I am taking live class only. Don't worry about it. So image is forming at focus. Nature of the image is real and inverted. Size of the image is highly diminished. Coming to the next one. So pole, focus, center of curvature. Object is placed object is placed beyond center of curvature. Beyond center of curvature. Image is forming between C and F. So the image will form between C and F. Here object is beyond center of curvature. Beyond C, image is forming between C and F. Nature of the image is real and inverted. Size of the image is diminished. Object is placed at C. Object is placed at C. Image also will form at C itself. Object at C, image also will form at C. Nature of the image is real and inverted. Size of the image same size. Coming to fourth one. Object is between C and F. Nature of the image is real and inverted. Real and inverted. Enlarged image. Coming to the fifth one. Object is placed between F and P. Object is placed between F and P. Image will form. Image will form behind the mirror. Behind the mirror. Nature of the image is virtual, erect, and enlarged. Erect and enlarged. Virtual, erect, and enlarged. Virtual, erect, and enlarged. Next one. Next one, we are going to one more. Is it clear? Any doubts? Convex mirror. So convex mirror, object is placed at infinity. Object is placed at infinity. One light ray I am taking like this. Another light ray. So object is at infinity. Image is forming at F. Nature of the image is virtual, erect, and virtual, erect, virtual, erect, and highly diminished. Coming to the second one. So pole, focus, center of curvature. Object is placed between anywhere between infinity and pole. One light I am taking like this, it will reflect back. Another light incident at the pole, it will reflect back. Mm. So object is placed between P and infinity. Image is forming between P and F. Nature of the image virtual, erect, and diminished. Virtual, erect, and diminished. So this is about convex and concave image formations. Next one, sign conventions. Sign conventions. So new Cartesian sign convention. So in the direction of incident rays, all measurement will be taken from the pole. All measurements we are taken in the pole in the direction of incident rays. Object distance, image distance, focal length, all are positive. Opposite to incident rays. Object distance, image distance, focal length, and radius of curvature, all are negative above the principal axis. So height of the image and height of the object positive below the principal axis. Height of the image and height of the object negative. So in that all measurements will be taken from the pole. In the direction of incident rays all are positive. Opposite to incident rays all are negative. Above the principal axis all are positive. Below the principal axis all are negative. So here I am considering. So here I am considering. So all this is the positive x-axis, negative x-axis, positive y-axis and negative y-axis. Okay. So this is about sign conventions. All measurements will be taken from the pole in the direction of incident rays all are positive. Opposite incident rays all are negative. Above the principal axis all are positive. Below the principal axis all are negative. Okay. So these are the sign conventions. Sign conventions. If you like this video, please do like, share, and subscribe to Student the Brand. Okay. So this is your Sivasap from Student the Brand. So if you like the content, if you like my explanation, So if you like this video, please do like, share, and subscribe to Student the Brand. If you like my explanation, so please support. I'm doing for students' sake, for them to teach in a better way. So I'm doing all these things. If you like this content, if you like these videos, please do like, share, and subscribe to Student the Brand. And so inform to your friends, inform to your juniors or seniors regarding YouTube channel Student the Brand. So thank you so much for your support and being with me. So supporting. So I'm grateful of you. So thank you so much.